Hi future doctors, welcome to the next class. In this class, we will discuss about motional EMF. So a rectangular frame is going to be placed in uniform magnetic field. Now magnetic field is not changing, it is going to be constant, but a conductor, a wire or conductor PQ is moving on this frame. You can take M, N. So M, S, R, N is the frame. So this PQ conductor is going to be moving either towards left or towards right. That is your wish. So how we will take means I am taking in this case towards left. So if it is going towards right also, we are going to calculate, that is secondary. Now this conductor is going to be moving like this towards left side. So magnetic field is into the board. Whenever it is moving like this, see here, what is changing means its area is changing. So whenever this area is changing, magnetic flux is going to be changing. Like this, whenever it is going like this also, area is changing, therefore flux is going to be changing. Number of field lines passing through this area is going to change. At the time, so what is our formula for induced EMF? E is equal to minus d phi by dt. So minus d by dt of, so we can write B A cos theta. So what is the magnetic field intensity direction means? Into the board. What is the area of direction? Area is going to be, let us assume, away. Then theta is going to be BA cos 180. Cos 180 minus 1. So d by dt of BA minus 1 into minus plus by rho. So this B is going to be constant. Magnetic field is not changing. Therefore B d by dt of area is changing. How area is changing means length of this conductor is PQ. PQ conductor length is going to be L. So this is nothing but X you can take. So X is going to be changing. L is constant. Therefore area can be written as L into X. In this who is changing? X is changing. Therefore L remains constant means right outside. So B L. So this dx by dt we can write it as velocity of this conductor. Therefore, induced EMF E is equal to B L. So that is nothing but velocity of the conductor V they will write. Therefore, simply we will call BVL. This is nothing but induced EMF. In vector notation, induced EMF is scalar. In vector notation, V bar cross B bar dot L they are going to write. L is nothing but length in which direction you are going to take. So this is nothing but vector notation, but mainly you have to remember this formula BVL, velocity if they give. Now induced EMF is generating. Let us assume resistance of this wire. This frame is not having resistance. Let us assume if it is having resistance also, how to solve we will see. So this wire is having capital R resistance. Let us assume. Then how much current is passing within this P and Q, and which is the higher potential, which is the lower potential, and what is the direction of the current. So this direction of the induced current, so direction of induced current is measured by Fleming's right hand rule. So already we used left hand rule. Now this is Fleming's right hand rule. Again we have to keep our three fingers like this, perpendicular to the, each finger is going to be perpendicular. Forefinger always represents field. So thumb represents motion of the conductor. Already we gave this. Forefinger represents field. Which field? Magnetic field. Thumb represents motion of the conductor. That is nothing but velocity. Then center finger represents current. Here which current means induced current. Induced current is going to be represented by center finger. Now see, most of the conductor towards left, magnetic field is into the board. See the center finger is coming downwards. This is the velocity. So this is going to be magnetic field. Now center finger represents current is going to be downwards within this. So if it is going to be downwards, now which is higher potential, which is lower potential. So this current is going to be downwards. Already we discussed current electricity. Therefore, try to say this which is correct from your side. So this is P and Q, it is not changing. P and Q, P and Q. Now I am writing or I am drawing. So positive, negative. So negative, positive. Which is correct and why? If you say which is correct and why? This is nothing but current I, induced current I. Which is correct means always current starts from positive end. So like this it is going to be moving. Therefore, current direction is downwards. So P is at lower potential, negative. Q is at higher potential. Correct? This is only correct now? From positive potential. So here already we have given the direction. So it is coming. So from positive end, always it will be going like this. Towards negative we should get. For battery always we will show like this. If a bulb or resistor, current will be starting always from positive terminal. Therefore, this diagram is correct. This is wrong. If you got any confusion, means which is higher potential, lower potential, like this if you draw, you can get the answer. Now, current is passing like this. So, within this loop, clockwise or anti-clockwise, this is going to be clockwise. How much current passing within this PQ? So, I is equal to E by R. What is induced EMF? So, BVL by R. So, if a current carrying conductor is placed in magnetic field, how much force acting on this? F is equal to BIL sin 90, because so this length is perpendicular to magnetic field. So, BIL, force acting on this current carrying conductor. So, this one already in moving charges we discussed. How much power? So, power is nothing but we can do in two ways, force into velocity. Already we completed this in work energy power. Now, what is force? BIL into V. So, again what is I? What is I means? BVL by R. So, B into BVL by R into L. Therefore, power formula B square, V square, L square by R. Correct? So, cross check, multiplication, any change is there? B square, V square, L square by R. This is the force. This is the power. Like that they may ask anything. Whichever they are asking, we can do all those things. If this frame is also having resistance, let us assume. So, resistance is nothing but R, S. Resistance of this frame we are taking, or RSR, or capital R. Any one you can take, just for our convenience we are taking RS. Already this wire is having resistance capital R. So, if you are drawing the battery, so this wire resistance capital R, it is connected to RS. Therefore, how these two? This is Motional EMF E. Then what is the current? I is equal to E by R plus RS. In current density we discussed this. Isn't it? What is E we have to write now here? BVL by R plus RS. Like this we are going to write. So, for this you can calculate if magnetic field is outside, conductor is moving right side. So, what is the direction of the induced EMF? So, induced EMF formula is this one, BVL. So, in this one logic you can apply. Here B, V and L, these three are perpendicular. You can cross check if you want. B is into the board. Into the board means minus K cap. So, length is along Y axis. So, velocity is along negative X axis. So, Z, Y, X. These three are always perpendicular. Whenever these three are perpendicular, then only we will get induced EMF. That one we will discuss in next video. But presently in this, you got one main important formula. E is going to be BVL, and another important one is direction of the current, which is at high potential, low potential. They are going to ask how much current is passing. This is generally we can do. I is equal to V by R, voltage by resistance, and force acting on this power, and if this frame is also having resistance, how to find the